Hello everyone. Let's provide the real solution to this problem very quickly. 8 to the power of x plus 2 to the power of x equals 68. Okay, so 8 here is the same as 2 to the power of 3, then multiplied by x plus 2 to the power of x equals 68. Now, what I will do next is to rearrange this first term here. So we can have 2 to the power of x, then we have 3 outside, plus 2 to the power of x equals 68. Now, the reason for this arrangement is for me to have 2 to the power of x in two places, right? Now, let a letter represent 2 to the power of x. So let y be equal to 2 to the power of x, so that here we shall have y squared, okay, y to the power of 3, then plus here we shall have y. Bring 68 to the left, we have minus 68, and then everything is equal to 0. Now what do we do from here? Remember that this 68 has a factor of 17, right? Okay, so if I write it here, okay, that means in place of y, I'm going to write 17y, because 17 is a factor of 68. But then, what do I attach to 17 here to give me 1? Like 17y minus what will give me 1y? It is 17y minus 16y. Then minus 68, giving us 0. Because from here now, 17y minus 16y will give this. But remember that it was 17y that we got as the factor of 68, right? So let's rearrange this again. Y to the power of 3 minus 16y plus 17y minus 68 is equal to 0. So that this way 17y and 68 can be factored, right? Now come back here. Let's group these two and factorize. Y is common to those two terms. Here we have y squared minus here we have 16 because y is already out. Then 17 we said is a factor of 68, so I'll bring it out. We have y over there, right? And then from there, y 17 into 68 will give us 4. Okay, and then everything is equal to 0. Now I'm going to continue with this because at this moment nothing is common to both of them. So y into y squared minus 4 squared plus 17 into y minus 4 is equal to 0. The reason for this is for me to be able to apply difference of two squares, okay? Now, applying difference of two squares, we have y into y minus 4 into y plus 4. This is for what we have in this bracket alone, right? Then I have plus 17 into y minus 4, which will be equal to 0. Please remember that we are getting only the real solution. Now from here, y minus 4 is common and it's over there. So factor out your y minus 4 and close it up. Then here we have y into y plus 4. Okay, so this is what we have. Then we have plus 17, and then this will be equal to 0. This will be equal to 0, right? Now let's open the brackets. Y minus 4. Remember, it's only this one that I want to open, the one on the inside. So y times y will be y squared plus y times 4, that will be 4y. Then I have plus 17, which will be equal to 0. Now we apply 0 product rule to solve this, meaning that either of these must be equal to 0. But a reminder is that we are looking for the real solution of x. So let's deal with this first, this quadratic. So we have y squared plus 4y plus 17 is equal to 0. The question is, can this give us a real solution? Okay, now if you want to know how to do it, just bring out your discriminant, right? Remember that the formula is y is equal to minus b, positive or negative, square root of b squared minus 4ac. Everything is over 2a, right? So if you want to get the discriminant alone, what you will do is get what you have in this bracket, in this square root sign. So your d will be equal to b squared minus 4ac. And then our b squared now becomes 4 squared because b is 4. Okay, we have 4 squared minus 4 times a. A is the coefficient of y, and that is 1, multiplied by c, which is constant, 17. So if I multiply this now, I'm going to have 16 minus 68, and this will definitely give me a negative value. So if it is negative, then it will be rejected because it's not giving us a real solution. Now let's get straight to the one that will give us a real solution, and that is this linear equation, which will be y minus 4 equals 0. Okay, the linear equation will be y minus 4 equal to 0, and then this means that y is equal to 0 plus 4, and then it's a confirmation that y is actually equal to 4. But then remember, let me finish it here. Remember that we never had y in the equation. Look at the original equation again. 8 to the power of x, 8 to the power of x plus 2 to the power of x equals 68. So we are not having y in the equation, but rather we had x. But remember when we say that y is actually equal to 2 to the power of x. So this means that 2 to the power of x, which is y now, is equal to 4. Okay, and then from here, make them have the same base. So 2 to the power of x will be equal to 2 to the power of 2. Now that the bases are the same, what do we have as the, okay, sorry, this is 2, because 2 to the power of 2 is 4. So we can conclude that x is equal to 2 because the powers must be equal, knowing that the bases are equal, right? So this is what we have. But then let's put it back into the equation very quickly, straight to the original equation. We have 8 to the power of x plus 2 to the power of x equals 68, and we're having 2 as x. This means that here we are having 64, because 8 to the power of 2 is 64. Then 2 to the power of x, that will give us 2 to the power of 2, and it is now 4. And then what is 64 plus 4? 68. So this means that we are very correct to say that x is equal to 2. Thank you very much for watching.